Hello guys, welcome to my tutorial today. If you have not subscribed to my YouTube channel, please do subscribe to my YouTube channel, like all my video in order for you to get the full video of this tutorial. Also follow my Facebook page in order to get the full tutorial of this video. You can also follow my TikTok page for you to get update of all our videos also. But in order for you to get the full video, you need to follow my Facebook and my YouTube channels. All right, thank you. And you may want to support us so that we can give you a good quality video with good sound track, and so that we can serve you better. You are also welcome. And at the end of this video tutorial, there is an assignment that is given for you to solve. Comment your solution and answer on the comment section. We will look at it and see if you are getting it or not. And if you have problem with basic calculation in maths, chemistry, physics, you also comment on the comment section so that we make video for that. All right, thank you. Last week, in our last class, we solved question on heat energy, WAEC questions, and we also gave assignments. If you have not solved the assignment, we are still hoping that you solve and comment a solution. Today, we are going to look at heat energy questions in Jamb. And so we are going to also give assignment at the end of it. So if you have anybody in secondary school or any person that is preparing for WAEC, Jamb exams, please draw the attention to this my tutorial. Let the person subscribe to my YouTube and follow us on our Facebook, because there's a lot of things the person will learn. All right, today we'll be looking at a Jamb question, so let's go straight to it. Here is Jamb question 2004. Says the change in volume when 450 kg of ice is completely melted is the density of ice is 900 kilogram per meter per cube, and then the density of water is 1000 kilogram meter per cube. All right, so of ice is giving us mass of ice, that's the formula, all over the density of ice. All right, so we need to get the density of ice, and given that from our parameters, okay, let me just put all of them down. Then the volume of water is equal to mass of water all over the density of water. Okay, mass of ice is equal to the mass of water here. So we are going to write our parameters. So for the question, we are given that the mass of ice, which is equal to mass of water, is equal to 450 kilogram, right? Okay, and then we are given density of ice, which is equal to 900 kilogram per cubic meter, and then density of water, which is equal to 1000 kilogram meter per cube. All right, so now we go straight to substituting. Then to get the volume of ice will be m ice over density ice, which is equal to 450 over what density of ice, 900, and that is 0.5 meter cube, right? So that is volume of ice, and we will also look for the volume of water. The volume of water is mass of water over density of water. Now the mass of water is the same as the mass of ice, which is 450. So we say 450 over 1000. You get it 0.45 meter cube. So we have got the two volume. Now let's go back to the question. They say the change in volume when the solid changes to water or to liquid. This is more like a latent heat. We are going to solve a question involving that. All right, so change in volume will not be the volume of ice minus the volume of water. We say 0.5 minus 0.45, and that will give us 0.05 meter cube, and the answer is C. So that's the solution for this. Sorry guys, the solution I solved the other, I didn't know the video cost some of it, but this is the solution what I explained in the other class. Hope you can see it clearly now. So sorry for that. That is the solution here. Okay, now what to solve another one is 5 times 10 raised to minus 3 kilogram of liquid at its boiling point is evaporated in 20 seconds by the heat generated by a resistor of 2 ohms. When a current of 10 ampere is used, the specific latent heat of vaporization of the liquid is. So here now they ask for the specific latent sorry. Alright, last class we looked at heat capacity. I would say this capacity refers to the amount of heat energy required to raise the temperature of a body by 1 degree Celsius 1 Kelvin. And the specific capacity is the amount of heat energy required to raise the temperature of 1 unit mass of that substance by 1 degree Celsius by 1 Kelvin. So latent heat is just the opposite of heat capacity. Latent heat, in proper definition, it refers to the amount of heat energy required to change the state of a substance without changing its temperature. While specific latent heat is the amount of latent heat required to change the state of 1 unit mass of a substance, usually measured in joules per kilogram. Okay, that's the proper definition of it. Now let me explain it in layman terms so that even if you are sleeping, they wake you to differentiate between latent heat and heat capacity, you will be able to know what to say. Okay, the simple difference between latent heat and heat capacity is this. For heat capacity, the temperature of the body changes, but the state of the body remains the same, remain unchanged. While for latent heat, the state of the body changes and its temperature remains unchanged. You see the difference? I'll come again. For heat capacity, the temperature of the body changes, is what is changing. The temperature alone is what is changing, but the state of the body itself, it does not change. But for latent heat, the body itself changes. The state, that is its state, changes, but the temperature do not change. I give you an example. Let's say we have a copper. You heat copper. The temperature of the body increases as a result of the heat you applied on that copper. But the copper still remains copper. It does not change. If the solid is solid, if the liquid is liquid, it does not change from solid to liquid. That's the state. At that state, when you say state of matter, it's solid, liquid, gas. So the state of the copper, if it is solid, it is solid. It doesn't change. That is heat capacity. When you apply heat to it, the state of the body remains the same. The only thing that happens on that body as a result of the heat you are applying to it is that the temperature rises, is what is rising, right? Okay. Then for latent heat, is a opposite of the heat capacity. For latent heat, when you apply heat to that body, the temperature will not change at all. It is the body that will change. Example, when you apply heat to ice is solid. The state of that solid will change. Ice will melt to liquid, but the temperature remains the same. The temperature is already 0 at ice point. When it is melting to liquid, it is still 0. It doesn't change, right? It doesn't change. But what changes is the state of that ice. The ice is no more there. It has changed to liquid, right? That is what we call, at that stage where the solid change to liquid, that's what we call latent heat of fusion. And now that it has changed to liquid, if you keep applying heat to it, the temperature will still not change. But what will change is the body itself. The liquid will now vaporize to gas. That's what we call latent heat of vaporization. If you do not understand this explanation, you can never understand this again. It's very simple in a layman term. Latent heat, you apply heat to the body, the state of the body changes from one state to another, but the temperature remains the same. For heat capacity, you apply heat to it, the state of the body do not change, but the temperature changes. So that's just it. Alright, so let's solve this question. So let's go ahead and solve the question. We're going to read the question again. Say 5 times 10 ls per 3 kilogram of liquid at its boiling point is evaporated. That is latent heat. It's evaporated. That the liquid changes to gas. That is latent heat already, without hearing too much story. In 20 seconds, by the heat generated by a resistor of 2 ohms when a current of 10 ampere is used. The specific latent heat of vaporization of the liquid is, so we are looking for specific latent heat of that particular body, right? So here I will say electrical heat generated, because of course you can see that it's electrical heat because we are giving current and then all the parameters that involves in electricity. So the electrical heat generated is equals to the quantity of heat required, the heat energy required. Electrical heat generated is equal to the quantity of heat required, because for that body to change, that electrical energy generated heat that enables the liquid to change to gas. So the electrical energy is there, and it is equal to the heat that changed that liquid to gas. That's what we are saying here. Electrical heat generated is equal to the quantity of heat required to change that body to gas, right? So, and the electrical energy generated is square RT equals to, of course, the heat generated, which is a latent heat, which is that's the quantity of heat generated. Of course, you know that specific capacity, specific latent heat is given by mass times the latent heat. In case you see this in the equation, this formula I'm going to use. If you are given mass of that body, then the energy, then they say find latent heat. This is it. So the quantity of heat required for that particular mass of the body is this, and then the electrical heat generated is this. So we are going to write our parameters. Let me check if the video is cutting. Okay, everything is in start. Parameters. So we say mass of the body is 5 times 10 minus 3 kilogram. Then the time is given to be 20 seconds. Resistors, that is ohms, resistor, and we put ohms. It's given as a 2 ohms, and we put R because we have it on the formula. Here are 2 ohms. Then the current, which is I, is given as a 10 ampere. Is there any other thing? Okay, that's all. So we are going to we are looking for specific latent heat, which is this R, sort of looking for. So we make this sort of formula. And making that sort of formula, we're going to have IR squared RT all over L. So we now go ahead to substitute. So in substituting, we say L is equal to I is 10 square times R, which owns 2 times 20 all over mass, which is 5 times 10 minus 3. Right? This and this will give us a, you can this will put here. We can, okay, no, we are going to open this first. We have 100 times this and this will give 40 equals to 5 times 10 minus 3. Right, let's come up. So latent heat will now be 100 times 40 will give you 4,000, right? All over 5 times 10 minus 3. This minus 3 here will remove this 30, or you put it properly for those that are novice. Raised by 3 all over 5 times 10 raised power minus 3. Okay, you can, they will cancel. Because this one is positive, is negative. So if you apply the laws of indices, just like the last class I taught, you take this one, when the bases are the same, the powers does not matter. But since the bases are the same, if you take this one up, you become positive. So you become 5 over 10, 4 over 5 times 10 raised to 3 plus 3, which is 4 divided by 5, will give us 0.8 times 10 raised to 6, which will be if you remove this one, if you remove this 0, this point here to here, it's become 8 times 10 raised to minus 1 times 10, 6. I'm just doing this for those that are novice, but if you know what I do, you can get it fast without wasting time. Then this minus 1, if you apply the law of indices here, this 1 plus this will give us 8 times 10 raised to 5 joules kilogram per kilogram, and that's the answer. The answer is B. Okay, the last question we solved was on latent heat, and then that was last year question 2024, and then right now we want to solve another question of involving heat energy in expansivity. All right, so let me read the question. A blacksmith heated a metal whose cubic expansivity is 6.3 times 10 raised to minus 6 per Kelvin. The area expansivity is, all right, remember last time we solved question on area expansivity in WAEC. So I will define area expansivity as the fractional change in length of a material per unit change in temperature, right? And then we'll also solve question on I think volume expansivity, which is the same thing as the change in volume of a material by unit length by unit volume in temperature, right? So, and then here now they gave us if I should write my parameters. Here they gave us a cubic expansivity. Cubic expansivity is denoted by gamma, and then 6.3 times 10 raised to minus 6 per Kelvin. And here they say we should find alpha linear area expansivity, which is given by beta linear expansivity. So that's what we say we should look for. So you can't get this question if you don't know the relationship between linear, and because on the normal linear and beta they don't really have any relationship, but you can maneuver this question if you know the relationship between linear and alpha, beta and alpha, right? So, and then the relationship between, I would say the relationship between beta and volume expansivity and area expansivity is and linear expansivity is we say bit a linear, I don't mind me, cubic expansivity, which is gamma, is equals to 3 linear expansivity, 3 times length expansivity, 3 times length expansivity or linear expansivity. So, and also you need to know the relationship between beta or area expansivity and length or linear expansivity, because linear means length, right? Okay, so beta expansivity is equal to 2 times length expansivity. Area expansivity, beta is area, gamma is volume, alpha is linear or length expansivity. This one we call volume. You can call it cubic expansivity. They are all the same thing. They are both volume, right? Okay, so these are the relationship. With this, we can make headway, right? All right. So we can now get our linear expansivity here, and from this relationship, we can get our linear expansivity, and then use our linear expansivity substitute in beta to get beta, because that's what they asked us to find. Beta expansivity, which it is, and beta is area expansivity, right? So let's get linear expansivity. So it makes linear expansivity. So for formula here, we're going to have linear expansivity equals to what? Gamma expansivity, cubic expansivity or volume expansivity over 3. So we are given this already here. So we are just going to substitute the rest. So we are going to say 6.3 times 10 raised to the minus 6 all over 3. And when you divide, you are going to have 2.1 times 10 raised to the minus 6, isn't it? Per Kelvin. So this alpha expansivity. So now for here, now we cannot get beta expansivity, which is area expansivity. So we can say beta, which is equal to 2 alpha, will therefore be 2.1 times 10 raised to the minus 6 per Kelvin. So when you multiply 2 times 0.1, we are going to have 4.2 times 10 minus 6 per Kelvin, and that's our beta expansivity, and that's the solution. And the answer is C. All right. Thank you for following the tutorial today. Please help us subscribe to our Facebook channel. Go to our Facebook, search for our name at so put it on the type it on your Facebook search, click it, search for it, you will see it. You will see our logo. Our logos are the same. You will see it. Click it, follow the page, go and start studying all the questions yourself, like them, attempt the assignment, do the same for our YouTube channel, do the same for our TikTok, follow us. That's a simple way for you to support us. And then you can also support us if you want to go further, like donating, contribute your support on the account display on the screen, so that we can get a better video, get a better sound record and all those things to serve you better.